if you want to watch out for. Okay? Let the marks on the question kind of indicate how much work was required. Okay, if it's a 1 mark question, probably yeah, it's probably just one step. If it's a 2 mark question or even a 3 mark question, then you probably have to look out for some extra steps required. All right, so let's get going. I'm gonna have my calculator ready to go. So most of you are charging. That's probably a smart move. Okay, and maybe also for a few of these questions, I might just give you like the factorial notation, not necessarily the final number, because that's the most important thing, right? To get to that step where you show me the work that is required. And then, yes, of course, you always want to give the final answer. Unless it's a really big number, if I tell you don't worry about solving it, just write out how you would solve a question like this. That's a few exceptions here and there. What else should I say before I start? Actually, it should be very clear. It should be quite clear as to which branch you should go at the very beginning. Is this a permutation? Is this a combination, right? Like it should be, you should be able to read it as like, yeah, this is making teams, committees, hands of cards. This is not, order doesn't matter, or order matters, right? And yesterday I briefly touched on a question that kind of mixes these up. Remember, president, vice president, and then 4 others, right? Or setter, libero, and 4 others. It's not going to be very common where they're together, but just watch out for those scenarios, okay? All right. Identify whether each situation involves permutations or combinations. Explain how you know. Okay, so for 1A, I will do this on loose leaf. I don't know if you want to do the same. So appointing a chair, vice chair, secretary to form a committee of 9 students. Yeah, sorry, from a committee of 9 students. So you would say specific positions mentioned, right? Order matters. Therefore, this would be a permutation. And if you're picked first as a president, and then on a second arrangement you are the vice chair, right? Then it does make a difference. B, choosing any 3 of 5 flavors of fruit juice. What would you say there? It's a combination, right? Order doesn't matter. Order does not, emphasis on the not, matter. Combination. Having the flavors in that cup, that's all that matters, right? When you go to Booster Juice, they just throw it all in there, mix it up. They put the ingredients in there, and the order in which they threw them in there doesn't matter. Okay. C, forming a sequence of plus, right, or X symbols using 5 positive and 4 X symbols. What would you say there? So you have 5 of these, and you have 4 of these available. So it's almost like, hey, this is a word. Arrange this, right? It's a bit of a curveball here. What would you say? Permutation, combination. It does matter if you have 1, 2, 3, 4, 5. It does matter if in which order I put them in, right? It's a different code, doesn't it? Right? But there's a bit of a curveball in there. What do we have to consider? You remember this question? This is permutation. Order does matter, but what do you have? You have identical elements, identical objects. They're indistinguishable. So this is permutation. Permutation order matters involving identical objects or characters, right? Elements. So you would have to divide that out, right? So what is that? 5 and 4? That would be 9 factorial over, right? You have your 5 and your 4s, right? You need to divide out. Divide out identical. So it's still permutation though. It's still permutation, but with a little caveat where you need to remove identical objects, okay? The second one, I haven't done this question with you yet. I haven't done this one. But let's read it first. There are 5 roads between Albertville and Borland. So Albertville and Borland, there are 5 of them, right? From here to here, there are 5. And then from Borland, there are 6 roads between Borland and Colwood. There are 6 roads here, right? How many ways can a person go from Albertville to Colwood and back to Albertville if they pass through Borland both ways and do not take the same road twice? Right? So that's what needs to what you need to take into account. So you have to go through B to get to C, and then you have to come back through B to get back to A. How many ways can that be done? And so basically, from A to B, right, there are 5 options. To go from B to C, there are 6 options at first, right? You have 5 to go from here to there, 6 to go from here to there. When you're coming back from C to B, how many options do you have now? Somebody said 5, right? Can't use the same road again, right? So you're back to 5. And from B to A, how many are left? You used to have 5. You used 1 already, technically, right? So 4 on your way back. So that's how you do a question like this if it ever shows up. I don't know, did it show up in a homework question ever? I'm not sure if it did. I know in the textbook it shows up at some point. I just don't know if I assigned it. So what do we have? 30 times 20, right? Is that 600? Hold it before I go on. You told me there's a 10, right? 2 to 10 in a deck of cards. Did I mention that to everybody yesterday? Yeah, I reversed the reversal. Okay. Okay. Sorry, that was my bad. I was off yesterday big time. Not just this class, I was off everywhere. Maybe I should have gotten more sleep. Who knows? 3, how many passcodes are possible? I want you to make a change here. I feel like it's a little bit too busy. I don't know if you already worked through it. I apologize if you did. Can you change? Let me just have that up here. It's a slight change. It's not a big change. But if you go to question 3, the passcode has 6 characters. I want you to change that to a 6. And upon reading this again, when I worked through it, I feel like C and D should have been more specific because it doesn't tell you how many characters. So for C, I'm going to make sure we know that it's 6 characters. And for D, we're also going to make sure it's 6 characters. I just wanted to stay with the theme of 6 characters because most questions do that. Okay. Okay, so question 3, let me just fold this up here. There we go. How many passcodes are possible? If the passcode has 6 characters in it, and each character can be either a digit or a lowercase letter. So 0 to 9, those are my digits. So that's 10 options, right? And letters, right there, 26 letters. We know that. So that means that every single slot has 26 plus 10, right? There are 36 options per character. Does that make sense? Okay. A, therefore, it doesn't say anything about not repeating, right? So 1, 2, 3, 4, 5, 6. There's 6 slots. This would be the fundamental counting principle way of doing it. It's really 36 to the power of 6. And I will give you the number. And always have something as a unit. That's what they want in grade 12 applied. The province would take half a mark off if you don't put some sort of unit. Passwords, codes, you name it. Just put something on there and we're good to go. B, this is, if you look at the branch, this is this branch where repetition is allowed, right? Number of options to the power of, in this case, characters. That's what we did here. B, the passcode has 6 characters. Each character can only be a lowercase letter and no letters will be repeated. Okay, so how would you do this one? There's 1, 2, 3, 4, 5, 6. If no letter can be repeated, that means that we start with 36, right? With the 10 digits and 26 letters. And what will happen to the number? It just goes down, right? Because the number of letters is going down. So that's basically a case where there's no repetition. So it's from 36, we're going to pick 6, right? 36, pick 6. Sometimes I will ask you to write this out by hand and just reduce it as much as possible. But when it's answering a question, just type it into your calculator and get the answer. This would be, I gotta get this right because it's a big number. And I'm just gonna, yeah. But it should be less than before, right? It should be less than before, yeah. Each character can only be a lowercase letter. Oh, yes. Like, you mean like that, right? Thank you. So this would be 26, pick 6. I can promise you that this is still the right answer. Like I'm going by my key, but for the final answer at least. Thank you. C. The passcode must start with a lowercase letter, end with a digit. Each other character can be either a digit or a lowercase letter, but none can be repeated. I'm curious to see how you did this one. I have a feeling, I don't know why, but not a lot of you have done this one. So do this, how would you do that, this particular scenario? I'll give you 2 minutes to discuss with yourselves. Discuss with yourselves, like, hey, what should I do here? Okay. What would you do? All right. Start with a lowercase letter. Fulfill that requirement. Right? End with a digit. Fulfill that requirement. Okay. So now the kicker is what comes in here? What number will you start with here? 34? Yeah. Because you've taken a letter and you've taken a digit. So your total 36 is down to 34. Right? Because none can be repeated. So this is what it would look like here. So it would be 26 pick 1 times 10 pick 1 times 34 pick 4. If you want to look at it in that way, right? So that would be 289, 386, 240 passwords. Okay. Way to go. If you got that, you're doing good. D, there was no overlap, right? The letters do not overlap with the digits, so we didn't have to worry about perhaps there being cases, right? The passcode has at least one character repeated. And we want a 6. How would you do that one? This one will be, something like this will be on the test. And if you did your corrections, you know what I'm talking about, right? At least one character repeated, I'll go total minus no repetition. That is going to be my strategy. What kind of reasoning is that? Not all at once. It's called indirect reasoning, right? Where you're not going to attempt to find every single case. You're going to find the ones that do not apply and just subtract. Let me just fold this up a bit more. Okay, so for D, let me just cover that up. At least one character repeated, so I'm going to go total. Total was the 36, right? The very first answer would have been 36 to the power of 6 is my total. I got that from A, minus absolutely no repetition. Have I done that already? Absolutely no repetition? No. So I'm going to go like this. 36, pick 6. Right? So I'm going to, because this is, every single character is allowed in every slot. This only accounts for using each option once. So this ends up being, I'm just going to copy my answer here because it's a really big number. 2176, 782, 336 minus 1402, 410, 240. And that ends up being 77437, 2096 passwords. And there you have it. Okay. And last but not least is E. What needs to happen there? Passcode has 5 to 6 characters, but they're not repeated. So that would mean you can have 5 characters or 6 characters. Right? So there's definitely cases here. So for 5 characters, nothing repeats. You have 36 pick 5 plus 36 pick 6, right? Because this makes sure that you're not repeating anything. And that ends up being, I'll just give you the whole number here, 144,764,9280 passwords. And yeah, this you should at a test just give me that number, and then show how you're adding it up, right? You don't want to just, because if you get this wrong, then you would lose more marks than otherwise. You excited for tomorrow, guys? Probably excited to have this done and over with, right? Okay, next, let's go to 4. What would that be? Think about it first. If you already did it, maybe think about it again. If you did it right, I'll give you. Okay, let's read it. In how many ways can Adam? How do you pronounce that name in French? Benoit. All right, Benoit. Adam, Benoit, and Kiris, Dilip, and Eva be appointed to a student committee with 5 different positions under each set of conditions. So there's a couple of things distinguishable, right? Committee, oh, that's a keyword, that's a buzzword for combinations, right? With 5 different positions. It's like, wait a minute, committee, combinations, but then 5 different positions. So what's happening here? I kind of did that on purpose. This would be permutation because it mentions different positions, right? Oh, pause. Okay, let's keep going. So different positions, this wins, right? This tells us that this is actually permutation. And so combinations is out of the question here. Okay. So for A, if Kerry is to be president, right? Kerry's. So if you have 5 different positions, they're different, right? So if this is Kerry, then you only have 1. And so for the remaining, you have 4 factorial, right? So this would be 1 times 4 factorial, which is just 24, right? Lost my place here. That's 24 committees. Okay. For B, it says neither Benoit nor Kerry will be president. Okay. So the way I look at this is if this is your president position, you only have 3 members to fill that, 3 options. But then those 2 that you removed here can be used for the rest here. So this is still 4 factorial, right? So you used 1 and you're like, why is it 3, right? Well, it could be, right, there are 3 remaining characters, so you're kind of running 3 cases, right? It could be the first option, the second option, the third option, and then this could be anywhere you want, right? So this is 3 times 24, which is 72 committees. Okay. 5, backside, following, right? I know this is dry, guys. I'm trying my best here. I want to just give you one last go at it before you have to write your test, right? So try to follow along as best you can. Try to think about what's happening here, okay? At a child's birthday party, prizes are awarded for best costume, best craft, best cookie, right? Decorative cookie. And how many ways can prizes be awarded to the 15 guests at a party under each of these conditions? Each guest receives at most 1 prize, okay? So what do you think this is? Is this permutation or is this combinations? You're not making teams, you're not making committees. There's actually specific prizes. It's like first, second, and third place, or right, there's specific prizes, right? Awarded, right? Order matters. Order matters here. So we're going to say that we have three different prizes to award, right? And there's 15 guests. So this would be a 15, 14, 13 scenario. Or you can also write it as 15, pick 3, right? And that gives me 15, pick 3 would be 27, 30 ways that prizes could be awarded here. Okay. For B, each guest may receive any or all of the prizes. What would change there if it's worded like that? That's another way of saying repetition is allowed. Okay, I will say this underneath. Right here, repetition allowed, right? So what really happens is you have 15 options for the first prize, 15 for the second, and 15 for the best cookie, right? So every single prize, like every person can get them all, right? So this is really 15 to the power of 3 like this, which is 3,375 ways. And it makes sense that there are more options because you can repeat, right? So that's what that question was supposed to highlight, the different ways of writing it out. Okay. Repetition allowed, no repetition allowed. Question 6. Let me pull this up. This is actually, I want you to read it and try it. Okay. Before I do it, give you at least a chance to kind of orient yourselves, read the question, and then see what needs to be done. Don't give you a question 6. What is this? Permutation or combination? Permutation. May I ask why? Explain. Althea? Okay. So that is a hint, right? Work out the order. And different arrangements. You see that word there? The two that's also a buzzword. Different arrangements, right? The order. Work out the order. You're like, okay. And if you just think about pegs, right, being placed side by side, kind of, right, like to come up with different arrangements, it all hints towards order matters. So order matters. I'm just going to go perms, okay? I'm going to get a perm today. I don't have enough hair for that, but anyways. But what else do you notice? Identical. There another identical objects. So I don't mean to. I'm trying to sell the product that I made, right? But it's definitely permutation, and it would be right. One of these here, it tends to, like, you can't use it over and over. If you use a peg, you're down one, so it's no repetition allowed. And then here would be the identical objects, right? You're in this scenario right here. So yes, how many pegs do we have in total? We have 8 pegs, right? We've got 3 blue, we've got 1 white, and 4 black. Okay, so these are my identicals here, the blue and the black, right? So we would just go 8 factorial over 3 factorial, 4 factorial, right? And that gives you, the top is 40,320, the bottom is, this is 6, and this is 24. And then you just plug it in, and it's 280 arrangements. Because we don't want to count the one where we mix up the blues, right? Because they're the same. You won't be able to tell the difference between those arrangements. So we divide that out. We get rid of that. Okay. So here we go. 6 is done. Let's move on. 7. I feel like I could have made like an ABC out of that one, but I'll just leave it. We'll just leave it. A tourist bus. Actually, you read it. Give it 3 minutes. This one is a little longer. This is a combination question. Okay. 7. Order does not matter. Okay. Groups of 5. Groups of 5 are made, right? So there's no arrangement. There's no picture being taken. If it says, hey, how many ways can these people stand to take a picture? It does matter being in different positions. Yeah, go ahead. So let's go ahead and solve this. 7A. The people are selected completely randomly. So how would you do that? Well, there are 50 tourists on board, right? So out of the 50, I'm just going to go ahead and choose 5. So this is 2, 11, 8, 7, 60 groups. Okay, so that would be an easy one to answer. For B, it's asking that you want a group with 2 Asian tourists, 2 American tourists, and 1 European tourist, right? So they're basically saying exactly, right? So this is saying 2 Asian and 2 American, sorry, lowercase, and 1 European. Okay, that's what they're saying. So the group is comprised of this. Okay, so notice the and in there. So you need to have all of these to complete your group of 5, and it's in this case exactly 5, right? So how many Asian tourists do we have? 23. You have to choose 2. And how many American? 16 American tourists, and from those 16 we choose 2. And from the European group, there are 11. We would just have to choose 1 to make that happen, right? So 23 choose 2 is 253. 16 choose 2 is 120. 11 choose 1. Anybody? That's just 11, right? And so that's 333, 960 groups. So this is exactly, like I want exactly 2 Asian, 2 American, and 1 European in that group. It's not saying it, but it's really implied. Okay. Okay, now the funnest of them all. This next one would be worth 2 to 3 marks, so you got to watch out for that. This one would probably, I would still say this one could be 2 marks because you have to consider the and, right? So you got to watch out for that. Let's do 7C here. 7C. You want at least 3 Asian tourists to be interviewed. So at least that means 3 or 4 or 5. Okay. How did I do it on my key here? They're both the same amount of work, more or less. So I'm going to go, be careful here. 23, choose 3, right? There are 23 Asian tourists. I'm going to choose 3, so I'm going to do this first scenario here. So how many are left? How many tourists then? Because I need to still complete the group with 2 other ones. So that would be what? 27. Choose 2. Does that make sense? Guys, does that make sense? Yeah. Because I have 50 in total, a group of 5. Or out of the 23, I'm going to choose 4, right? This is that scenario. And I still need, from the 27 remaining, I still need to choose 1. Or from the 23, I choose all 5, right? And I still need from the 27, I need to choose 0 from that. It's basically irrelevant. This choose 0 that's going to be 1. But I still think it's valuable to understand how things are happening. I also need you to understand that this does not affect the number of non-Asian tourists, right? Because this is a completely separate category from this one. So here we go. 23 choose 3. You're going to have to help me out with this one because I did it a different way. Maybe just double. Yeah, go ahead. Maybe double check my work here. 23 choose. That's the 8th option. So that's 1771 times. I'm going to do a separate one for the 27. Choose 27, choose 2. That's 351. Plus, and now I'm going to just go copy and paste. I'm going to have a 23 choose 4, which is 8855. 27 choose 1 is just 27, correct? Plus 23 choose 5. That's 33,649. And that's just 1, right? 27 choose 0 is just 1. So here we have it. I'm just going to go ahead and multiply these two. 621, 621, 8855 times 27 is 239.85 plus 33649. That's a grand total of 894,355. Hey, it matches my answer. I'm a happy fella today. I did it the indirect way. I went total minus no Asians, minus, right? Like so, it worked out to the same answer. So you decide what you want to do. This would definitely be a 3-mark question, in my opinion. So here you have it. Okay. So 7C is done. Let's keep going. I'm running against time here, guys. 8. You figure that one out. Read it quickly. Read it quickly. I need you on your toes. I wanted to do AC, but I think it wouldn't have given me enough time to review the rest. I wish to order, if you wish to order, order, permutation. Nah, don't fall for it, right? Order doesn't matter, does it? Fruit flavors, a shake, whatever, it doesn't matter. You want to make a juice with 3 different ingredients, but none of them are premium. So you don't want to include the premium as your option. So you go 8 plus 7, you have 15 options, right? So you're going to go 15, choose 3, done. 455 juices. Hey, this would be a good way to impress someone, right? First date, right? You look at all those flavors, like, hey, do you know how many 3 flavored shakes you can make? 15, choose 3, 455, right? It's very impressive. Don't do that. Might go sideways, but anyways. If you wish to order a juice with 2 vegetables and 1 fruit, how many different juices are possible? There we go. So you want exactly 2 vegetable options and 1 fruit in there. So how many veggies do you have? You have 7, and you're going to choose 2. And from the fruit, you have 8. You're going to choose 1. That's all it's asking for there. Remember, these 2 add up to the flavors you're interested in, or number of people in the group. In this case, you want 3 flavors, right? And these are the options for those particular ones. So 7, choose 2. Where am I at here? That'll be 21 times 8. And that's 168 juices. Okay. C, if you wish to order a 5-ingredient juice with no more than 2 premium ingredients, how many juices are possible? You're not going to like this one, right? On a test, you're going to skip this one. I'm going to come back to it. No, don't do it. Don't skip it. You can do it. Just lay it out. Like, what do I need to do here? Okay, so 5 ingredients, highlight that on a test, right? And you want no more than 2 premium. No more than 2. So that means 0 premium or 1 premium or 2 premium, correct? That's what this is saying. And hold it. So if I have 0 premiums, right, that means that I have 5 non-premiums. In this case, I have 4 non-premiums. And in this case, I would have 3 non-premiums, correct? That's the implication, because you still want 5, right? 5 flavors altogether. So let's go and set this up. 0 premiums. That means that I'm going to choose from the 12 premiums, I'm going to choose 0, and how many flavors are remaining if I used up 12? There are 15, right? If you think about it, there are 12 premium, and then there are 15, 8 and 7 that are non-premium, and I'm going to choose 5. Or the other option would be from the 12 premium, I'm going to permutation. What's going on? That's not right. Right? And then 15, choose 4. Or from the 12, I choose 2 premium, and I take my non-premium options and I pick 3 in that case. So these are the options that I'm going to use. Okay, so I'm going to give you the numbers here. This is 1 times 3003 plus this is 12 times 1365, and this is 66 times 455. If you add it all up, you get 49,413 juices. Now this gets you a third date, right? If you come up with this in your second date, right? That's a pretty good, impressive answer. Anyways, don't ask me for dating advice, obviously, right? So let's go to 9. Sustainability group at Sisler, 60 members doing recycling, 10 composting, 7 doing gardening. A committee needs to be formed with 2 people from each recycling and composting and 1 from gardening. How many different committees are possible? I think you can handle this one. Is this combinations or permutations? Let's just make that clear. This is a combinations, right? You're making committees, right? So this is definitely slam dunk combinations. I'm going to leave that to you. I will scan the key. I already scanned it. I just have to click post, and then you'll see that there. How's that? Because I'm looking at my key at my time actually, and if I have time at the end, I come back to this. I promise. So let's go 10. I'm going to go to question 10. I'm going to leave some maybe half a page or so for question 9. And then go straight to 10, which I can do on here actually, right? Given the grid below, assuming you must follow lines, you can go left or up. So by the way, this got cut off here a little bit. This is a C here, and this is supposed to be a B. If there is no C in the middle, or if you need a bottleneck, just give it a letter, okay? So for A, it's asking how many paths are there from A to B along any route? Do you understand what that is saying? It's basically saying don't worry about C. Okay, so let's do the formula for that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks. And then I just have to count how many verticals and how many horizontals, right? So 1, 2, 3, 4 verticals and 6 horizontal steps to be taken. This would be a good time to practice simplifying. So if I see something like this, 10, 9, 8, 7, 6 factorial, stop. Watch what I'm going to do with the 4. I'm going to go 4, 3, 2, 1 times 6 factorial, right? That 6 factorial goes here. Those I can cancel out just nicely. There will be probably one where I ask you to simplify it as much as possible. Okay? So this is a good time to practice that. And then you just try to find common factors, right? And it doesn't really matter how you do it. For example, I will go, the 4 goes in here once and it goes in here twice, right? The 2, 10 and 2 have a factor of 2 in common, right? 2 goes in here once, goes in here 5 times. 3 goes in here once, goes in here 3 times. And if you notice, everything in the denominator is 1 now, right? 1, 1, 1, 1. This is also gone with that. So you're really just left with 5 times 3 times 2 times 7. And that's 210. Sorry, you can't see that, can you? My bad. 210 left. 210 ways, I should say, to get there. And then for B, we have to go from A to C, right? And C to B. So you have to do it in steps. So if you're going from A to C, that's 1, 2, 3, 4. 4 steps, and it's 2 each way. And from C to B, you're going to go 1, 2, 3, 4, 5, 6. 6 steps. And it's 2 vertical, 4 horizontal. This ends up being 24 over 2 times 2 is 4. 6 factorial is 720 over 2 times 24, right? That's 48. This gives you 6 times 15, so that's 90 ways. And you can do the counting method inside and test it out if you want. If you look at the key, I have actually everything highlighted, color coded. It's prettier, right? So if you want to look at the key later on, you can do that. Question 11. Let me just peek what's left. Yeah, so question 11, you want to read that quickly and see what needs to happen there? First of all, figure out, is this a buzz cut maybe? Each of the, so this is definitely, if you look at all the pictures you have, right, it's just a 12 factorial. You just want to arrange, right? The word arrangement should give it away. They're pictures, so yes, they're categorized, like they have their subcategories, but the assumption is they're not the same, right? They're all distinguishable. And so you have 12 factorial, which is 479,001,600 ways of arranging that. Okay. B, the photos are placed in a single row, but the photos of the friends are placed beside each other. How many friend pictures do we have? There are 3 of them. The families are placed together. The photo families are placed together. And the vacation photos can be anywhere. So that means that you have 2 groups that must be together. And then from the 12, you subtract the number in the first group, you subtract the number in the second group. You will add the number of groups that have been created and slap a factorial to it. So that's 3 factorial, 8 factorial, which is it 9? 12 minus 6 is 6, 8. That's good. That's 1451, 520 ways of doing that. And what if I said they're not to be beside? Like how many arrangements can be made where the friends and the family are not beside each other? Then you would just take the total, subtract the ways that they can be grouped together, and then you have that, right? So that would be a 2 mark. Watch out for that. Unless I made you figure it out before, and all you need to do is grab and subtract, it's going to be worth 2 marks. Okay? The photos are placed in 2 rows. Okay? With friends and family on top, any order, and the vacation photos below. So this, I think, warrants one of these, right? Top row, bottom row. You cannot flip these. That's not an option. So really, you have 6 factorial here, and you have 6 factorial within here. So you can move them around anywhere you want, but you cannot do 2 factorial. So it's not like there are 2 groups now that you can flip yet. Okay, so they must stay, right, in that row. So that's really just 6 factorial times 6 factorial, which is 720 times 720, which is 18,400 ways. 18,400 ways. Nearing the end, I was able to fit this in, so I want to do at least one card, one standard deck of cards game, question, and that'll probably be it for today. So let's go to 12. By the way, you will notice I did not do any of those equations solving for n. I don't have time for that. I did one yesterday. So if you need to review that, just go and see that. I also assigned from the text. If you go into the book, there's that test review questions at the end. There are a few of those in there, so you can get that as well. Okay. So question 12. A game is played with 4 cards drawn randomly on a well-shuffled deck. How many hands consist of only a face card? So this is a guaranteed combination, right? Hands of cards. So you want, how many are face cards? That's actually saying exactly 4 faces, right? That's what that is saying. How many face cards are there in a deck? 12? Okay. 12, choose 4, correct? But can we make sure we understand that technically that means that how many are non-face cards? If there are 4 faces, 12 face cards, then I have 40 that are not face cards. Remember that? You need to understand that. So that means that from the 40 remaining cards, you're going to choose 0. That's why I do this, because that way you always remember there's a second component to questions like these. Okay, so 12 choose 4 is 495. 40 choose 0, that's just 1, so that's 495 hands. Boom, done. B. How many hands consist of only numbered cards? How many numbered cards are there? 36? So exactly, you got a minus a. So from 2 to 10, how many cards do we have there? Let's do a smaller experiment. If you have 2 to 3, numbers 2 to 3, how many cards are we talking? 2 and 3, that's 2 cards, right? So 2 to 10 would be 9 cards. 9 cards times how many suits? 4 suits. That's 36. So you were right. 36 cards that are numbered. Perfect. So we're going to say, what did the question say? Only numbered cards. So from the 36, we choose 4. And how many are non-numbered? 16, right? 16 non-numbered, because they got to add up to 52, right? So 16 choose how many? Zip, right? So 36 choose 4. I don't have that. So let me just go copy that quickly. $58,905. Okay, that's the answer, because this is 1. We know that that's 1. So that's how many hands will only be numbered. You've got more numbered cards. It should be a bigger number than just face cards, right? Those are things you need to check when you're doing these things. C. Why is the sum of A and B, right? Why is it that both sums, like A and B, like adding these up, do not add up to all possible hands? How many possible hands are there? 52, choose 4, right? Let's do that real quick. 270, 725, sorry. Possible. You can tell that adding these up will not get you anywhere close to this, right? And so why is that when we add these up, that it's not adding up to the total? Because these are all the face cards, and these are all the numbered cards. What are we missing? The aces. We haven't included the aces. So it's just trying to get you to think a little bit. A and B, right, are not considering aces, right? I have 8 minutes. Let's do 13 and then we'll call it. I know you're going to work hard in this class. You probably already noticed that, right? That's just how life is going to be, guys. It's not going to be easy, but it's still fun. Okay, how many different 5 cards hands can be made from a standard deck of cards? No restrictions. So that's just 52, choose 5. I'm just going to give you that. That's 259, 8960 hands. Okay, and so that's A. There are no restrictions there. B, exactly 3 black cards. I won't do that one. I'll skip that. Look for the key. C key, because that's exactly. C, have at least 1 black card. At least 1 black card. What would be easier to do, direct or indirect? Direct would be 1 or 2 or 3 or 4 or 5. I will go total minus no black cards, right? You can do direct. You're going to get there, but there's a lot more work and more potential to get it wrong. So I'm going to go 52, choose 5. That's the total number without restrictions minus, can we just think this through? No black cards. So that means that out of the 26 reds, I'm going to choose 5, right? And out of the 26 black cards, how many am I going to choose? 0. I'm just going to give you the answer. 253, 3180. And I can read numbers, guys. It's just I need glasses, I think, because I can't see the commas. So that's 2,533,000 and then some cards, right? Or hands. So I will just say this. These are, you're choosing, these are reds, no black, right? That's, I need you to understand that there's always a not to something, right? Numbered cards, not numbered. Face, right? Like whatever the scenario throws at you, that's what you need to consider. I think I'm going to stop there. I want to give you still the same speech as yesterday. So I told you where you can get extra review material, right? I put it in your notes, and I'll put it up again. And remember, you will get as much out as you put in. Okay, some of you are putting in a lot, I know, and you're still saying, but Mr. Dirksen, I'm still struggling. I'm not guaranteeing you an easy ride. That's not what I'm going to guarantee you, but I can guarantee you growth and success to a certain degree. Okay?